Right then, Year 11. Welcome back, and this is the third part where we'll go through the last sort of question, the third question. Now, as we've gone over the question 1 and question 2 are fairly straightforward. Question 3, though, is where you're going to have to think about your drawing skills and also your mathematics skills. Now, we have here on the page 9 the first question. Now, it's usually a slow ease into this particular one, where it will question you a little bit about your knowledge about machinery. And you can see that on this particular one, we have got a centre lathe. And it says, shown below are two pieces of equipment used in engineering workshop. The picture below on the left shows a spring-loaded chuck key and is used to tighten the jaws of a centre lathe. So you can see you've got the handle here, comes down here, square bit on the end, which locates into a square section just there. The spring, you have to push against it in order to locate it into that square section, turn it back and forth to either open or close the actual jaws to accommodate your piece of material, your stock. Now, it says, explain why the chuck key has a spring. I'm sure you all know this one quite straightforwardly. One of the most dangerous things you can do in a lathe is leave the chuck key inside that chuck, because if you turn it on, it starts spinning, that chuck key is going to go flying out and could cause quite serious injury. Now, you can see on here, this spring, because you have to push against it and compress it, if you let go of it, which of course you would do if you were going to turn the machine on, it would push the metal back out and it would fall out of the chuck. So it's a safety measure. So really that's what they're looking for. They're looking for 2 points on here. You need to explain it, justify it. So you need to go, you push down on and compress the spring when you're actually tightening or loosening the chuck. And if you let go of that force, it automatically pushes it out, therefore reducing the risk of it being left in. And then we come on to the state-free precautions you would apply before using the centre lathe. Now, this should be pretty straightforward, actually. You should be able to sort this one out fairly easily. It's simple stuff like, well, not leave the chuck key in, wear an apron, tie your hair back, make sure everything's tightened up correctly, that your work is centred in the actual chuck, that there's only one person on it at one time. Any of these kinds of answers are what they're looking for. So, as I say, this question is quite an easy one, and sort of eases you into the overall third question. Then we come on to the one which is the maths question. Now, this is the B one on the third question. It states here that mobile phones and tablet devices are used daily to watch videos and films. I know I do use them. Stands are purchased to hold the device at an angle so that users don't need to hold it. And you can see here a quite nice one, which looks like it's been made out of aluminium. However, they're talking here about something that would happen in a school. So a team of pupils have redesigned a new stand, which they will manufacture from 3mm cast acrylic on a laser cutting machine. Below is a plan view of the piece of acrylic before it is heated and shaped. Now, you probably did this in Year 7, and it's bent up with a hot wire strip heater, line bender just on there so that you can get that in. What they're asking you to do, though, in this one, this is where the mathematics comes in, calculate the total volume of waste material removed from the slot labelled A. Now, we have to remember that this is a three-dimensional item. You're going to need to know an area of a circle, and we know that an area of a circle, as I've got just here, is pi r squared. So I put in here 10, which means it comes out as 314.6. Now, you've got both the diameter from side to side. The radius is the r. So you can see on this particular diagram, they've got a radius of r there. You're going to have to do something slightly different, and it's basically the same size because they've given you a different dimension there, a different style. They've given you a dimension for the diameter there. So again, you're going to have to half that, which means it will have a radius of 10 again. Now, this is how they would expect you to do it, and they've actually got, this is the mark scheme for it. An area of a circle, or two half circles, equals 3.14, which is pi, times 100. Now, what that basically means, it's 10 squared, 10 times 10, which is obviously 100. So you get 314. So they've actually made it quite simple for you, because you can almost do that mentally yourself without a calculator. So that's why it's 100 and not times 10, because of course it's squared. And they give you there A equals H times W. Now, that area equals height times width. Now, this is for the rectangle, because we've basically figured out the circle that these half circles make up. It wants you then to figure out the area just here, which is 40, and we know that that's a radius of 10, which means that the diameter must be 20, which means that height just there is 20. So you can see in the working out on this one that it needs to be 40 times 20, which is 800 millimeters squared. So you've got the 800 millimeters squared for the rectangle. You've got 314 millimeters, which is the area of the circle that makes the two end parts. And then it's got volume equals total times thickness. And that means that what you've got to do is think about it times 3 millimeters, because we know that the thickness of this piece of material is the standard size of 3 millimeters. Now, if you did just think of it as a flat 2D shape and forget about it being three-dimensional, you would have got one mark for the circle area, one mark for the area there, and one mark for it being added up. But you wouldn't get the last two marks. You wouldn't actually get the full marks, the full 5 marks. So you could get 3 marks for that, but you have to remember these items are actually three-dimensional. So you need to take 1,114, which is the total of the previous ones we added up, and times it by 3 millimeters, which gives us 3,342 millimeters squared. And that gets you the 2 marks at the end. As must be in millimeters cubed for the full 2 marks. So you have to make sure that you've got that 3 just at the end there to make sure that you're explaining that it is a cubic millimeter. Fun. But that's how it works, and this is the question that is going to ask you most of those ones. And it is a bit tough, but if you look at it, it does kind of make sense on there. Coming down, we have got the next question, calculate volume. That's the one we were doing, which is all 5 of them. And we come down here, the third part of that question. This is a picture of a surface angle plate, sometimes used to hold the workpiece square to the table during marking out operations. Complete the orthographic projection on the opposite page. The front view has been completed for you. The side and plan needs to be completed, and you've got 6 marks there. And if we come down onto there, you have got the 2 views. You've got a front view there, you've got a side view, and it's going to need to have the plan view. And you can see that it gives you a little bit of space to do that one. The actual answer on here says, to achieve the full 6 marks, both the side and plan views projections need to be completed. Side view, 4 holes to be drawn on the back in line with the side view. 2 vertical holes, which are also the hidden detail. 2 for the side view, 4 for the top view. Full plan view drawn in line with the front view should include 2 horizontal holes or hidden detail and 4 holes in line with the front view. So what you're there talking about there is you're taking this one, you're realizing that they've got the hidden details. You can see that we've got some hidden details on this view, which are these holes going through. You need, if you look at this one, you've got holes just there, 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 and there, which you've got there and there, and also there. And all those hidden details need to be in order to get the full marks. And what we're talking about is drawing a view down here, which is looking from above. Now, it's very difficult for me to go through that one. I will go through it in the actual lesson so that we can draw it. But this is a question that you can get 6 marks very easily indeed. And there are certain techniques like drawing a 45-degree angle off there and cross-referencing all the lines in order to get the perfect view. But I will go over that as a technique. And then finally we've got the second part. In the space provided, draw the symbol showing that an engineering drawing has been drawn in third angle projection. Now this is something that you should all be very familiar with. And if we have a look at the answer on here, it is the standard sort of cone that we use, and it's third angle. There we go. We have the top view there. We have the side view here. 1 mark for each image drawn correctly. They must be in the correct order. So you can get 2 views of that, and that will mean that you get the total amount. Now, if we come down, we have finally the very last question on this paper. State 2 pieces of information that should be included in the title block of an engineering drawing. Now, there's so many different things that you could include in this particular one. You could have the company name, the title of the drawing. That's obviously, say, you know, if you're thinking about doing your lamp drawing, it would be lamp drawing version 1, neck, whatever. The materials might be named, so you could put that in. The scale is a key thing to have on there. The drawing number or project number or job number. So which one is it? Because sometimes you have an exploded view and they have numbers to show which bits have been done as separate drawings. A date is obviously really important, and then personal ID or name. So if you put name down, and that's what they're looking for. So this one, again, really, really simple question. Overall, hopefully you can see that this system of doing it, I think that's the only one that might be a bit tricky for you, drawing, and I haven't been able to show you an example of how I would actually go for it. But it should be something that you can do, and I'd often say it's a good idea to come to this drawing one straight away and get it out of the way and then go back, because there's so many points just for that one. Hopefully these have been really useful for you. Go back over them, check out my other videos which should cover all the theory as well for your mock and beyond, and yeah, and hopefully I wish you all the best in the mock and also for the real thing.